Good evening, sir.
Good evening, sir. Good evening, sir.
Okay, good evening, everyone. Good evening, everyone.
Well,
Good evening, sir.
Am I audible to you all clearly?
Yes, sir.
yes, sir.
So today we'll be starting with a new chapter in chemistry. So in chemistry, we have already done two chapters, right? And after doing the next chapter, I think of just practicing a few questions of different level. We will increase the level and we'll practice a few questions from that. Alright. So what's the next chapter from chemistry?
Metals and non-metals.
Which one?
Metals and non-metals.
Metals and non-metals. Okay. So I think we should be continuing metals and non-metals later. Shall we start with carbon and its compounds?
Carbons and compounds.
Yeah. I think we shall start with carbon and its compounds. Okay. So let's see how to go about carbon and its compounds. Okay, let's continue with carbon and its compounds. So before we start, let's see. So let's see something interesting about carbon. See, as we know that there are nearly 118 elements. Okay, but there is some specific importance given to this carbon. Can anyone think why we are studying carbon? Out of those 118 elements, why we are giving importance to carbon?
So, because carbon can combine with a lot of other elements to form different compounds.
So can oxygen also.
Yeah, but
So
Yeah,
is it
so
because of number of allotropes it has?
yeah.
Is it because number of forms it's present in like in diamonds
No,
and gaseous
no,
form?
no, not diamond. We come to diamond later. See why we come about carbon. It's we observe life. See if you move in this universe. Okay, good evening there. So if you move in this universe from planet to planet and everywhere, as we know that scientists are searching for life. Are the scientists searching for life on other planets?
Yes, sir.
Yes, sir.
Yes. So they can find iron, they can find gold, everything is possible to find. Is there any planet where we can find wood?
No, sir.
Okay, what do you think if we find somewhere wood, then what would it signify?
That there is life on that
There
planet.
is life. Okay, so the thing that is very scarce in this universe is wood. The plants that you see around us, they are very scarce in this universe. We are up to now, we have found them only on Earth. There are so many planets, so many systems, and out of them, we have been able to find these plants only on Earth. So that is why where carbon comes into it. So our life, it is moving around carbon. How carbon? All carbohydrates. See, the carbohydrates, all the carbohydrates, fats, vitamins, proteins, all of them, they are made up of carbon. Their main constituent of all these molecules is carbon. So what all these molecules consist of? They consist of carbon, hydrogen, oxygen and nitrogen. Nitrogen is generally contained in proteins. It's not contained in carbohydrates and fats. So carbohydrates and fats, they generally consist of carbon, hydrogen and oxygen. So we want to see what are the properties of carbon. Our body is also made up of carbon. Our body is only made up of carbohydrates, fats and proteins. So can I say my body is made up of carbon, hydrogen and nitrogen? The answer is yes. So to study is we are focusing on carbon. Also, the number of compounds made by carbon, number and variety of compounds. So the number and variety of compounds that can be made by carbon, okay, that can be made by carbon. Okay. So what is the number, the variety that can be made by carbon is that, first of all, this carbon is like, there are so many varieties of compounds made of carbon that we have a separate branch of chemistry which studies the compounds of carbon, which we call separately as organic chemistry. So here another branch of science is being set up, which is there to study organic chemistry. So organic chemistry, organic chemistry is the branch of science which deals with the study of organic compounds. And all the organic compounds, they consist of carbon. That means there are certain inorganic compounds also which are made by carbon. Okay, see. So now I'm talk. What do we mean by this organic and inorganic? Okay. Can anyone tell me what do you mean by organic and inorganic? Yes, anyone who can guess what can be organic?
Organic consists of plants, animals, and which is
Yeah, a
basically
little close,
living,
a little close.
and inorganic is just rocks and abiotic. I guess.
See, originally when we were talking of organic and inorganic compounds, so it was something like this. Now we classify the compounds of carbon under two categories. One group of compounds, they are the inorganic compounds. The other group of compounds, they are organic compounds. So for the organic compounds or the inorganic compounds, in earlier or when we started with the study of carbon, okay, so organic compounds, they were considered to be the compounds which can be made only by organism. This was the older definition. I am not giving you the new definition currently. So this was the older definition, according to which we can call a compound to be an organic if it can be made only by organisms. Okay. That means it can't be made in the laboratory, only by organisms. So it can't be made. So it can't be made. It can be made in laboratory. Right? So if you try to make it, like suppose there are certain compounds I can try to make, but I won't be successful. If I have carbon and hydrogen and I try to make methane out of them, so carbon plus hydrogen, two molecules of hydrogen, they should combine to give us methane. But if I try out this in laboratory, this is not possible. It's not possible for us, given carbon and hydrogen, it's not possible for us to manufacture methane. Okay. Whereas the methane gas is produced from the body of the living organisms. Like it can be produced from cow dung easily. So there is a requirement of living matter to produce methane gas. And hence we call this compound to be an organic compound. Whereas if you talk of carbon dioxide, so carbon dioxide can be easily prepared. You can, if you just burn carbon with oxygen, so you are able to get carbon dioxide. See, both of them, they are compounds of carbon, but this carbon dioxide is an inorganic compound. Okay. But methane is an organic compound. Right? So not only methane, there were a large number of compounds like proteins, okay, carbohydrates. Is it possible for us to manufacture carbohydrates in the laboratory? Like suppose I want to produce glucose in the laboratory. Glucose is a type of simple carbohydrate. Okay. It's a simple carbohydrate having the formula C6H12O6. Okay. So if we try to manufacture this glucose in the laboratory, and suppose we are successful in making this glucose in laboratory, so do you think that we would require those plants and fruits and everything? Do you think we would require them? No. Since glucose is a form of food, so if we could manufacture our food on our own, then why should we be dependent on plants? Got it? So this was originally defined to be like this. Nowadays, we gave a new definition for these organic compounds. Okay, as because of a little bit confusion with these compounds, so the confusion with these compounds, confusion with the definition arose when scientists tried to create amino acids in the laboratory. Okay, so the creation of amino acids in the laboratory, it was a great step towards modernization of the biological sciences. So given certain specific conditions, the conditions were very hard. So under those harsh conditions, it was very, scientists were able to make ammonia. Scientists were able to make amino acids from ammonia, which is an inorganic molecule. See, ammonia can be made with nitrogen and hydrogen. It is an inorganic molecule, and scientists tried to make amino acids from ammonia, and they were successful to a certain extent. Okay. The experiments could not be carried out forward as the conditions that pertained, the conditions were very harsh to be maintained in a laboratory. But yes, it was verified that you can manufacture them, you can make them, you can make them. So we gave it, or we came with new definitions for the organic compounds. So I hope now you have understood a little bit about the organic and the inorganic compounds.
Yes, sir.
Okay. So see how close carbon is to us. In our body, glucose we are eating. We are eating carbohydrates. We are eating fats. Everything is that is made up of carbon. Okay. So that is why carbon is very important to life. The number of compounds that can be made with carbon are very helpful for our body. So that is why to study the life and life cycle, it's necessary to study carbon compounds. And hence, the study of carbon compounds has been divided. We make organic chemistry. Even in organic chemistry, also there are certain, it has again been divided into 12 branches. So there is a broad scope in this compounds of carbon. Okay. Now let us try to understand why carbon is different from other elements. Different
Sir?
means, yes,
Sir, could you show the previous page one, sir?
yeah. This was the previous one where we were discussing about organic chemistry.
Completed, sir. Completed, sir.
So see here. Now, so why carbon, how carbon is different from other elements? Okay. So we'll try to observe the element carbon. Okay, what is the atomic number of carbon? Is there anyone who remembers the atomic number of carbon?
20.
Yes,
20.
6. Atomic number of carbon is 6. It occurs at 6th position in the periodic table. Its atomic mass is 12. However, there are different isotopes of carbon which are available. So here we are discussing for carbon 12. That means carbon which has atomic mass 12. We also have carbon 14. We also have carbon 14, carbon 13 also occurs somewhere. But they are very less. Generally, we find carbon 12. So for carbon 12, the atomic number is 6. So Siddharth, how many protons are there?
Sir,
Siddharth, how many protons are there in carbon?
if the atomic number is 6, then 6 protons.
Yeah. So carbon has 6 protons there. How many electrons are there?
6.
Yes. How many electrons are there?
6 electrons.
6 electrons. Right. And what would be its electronic configuration?
Two comma four.
Okay, electronic configuration of this is 2 comma 4. Okay, so let's try to draw a diagram for this carbon, how the carbon atom should look like. Okay. So these are the two shells of carbon where you have, so here you have these 6 protons located inside the nucleus, 6 protons, and you also have location of 6 neutrons here. And this is well inside the nucleus, right? So inside the nucleus, here you have 6 protons and 6 neutrons, right? I'm writing here. The nucleus has 6 protons and 6 neutrons. Surrounding the nucleus, you have K shell. So this, okay, so this is your K shell. This is your L shell. And now if I fill the electrons over here, so as per the given configuration, the K shell has 2 electrons and the L shell has 4 electrons. All right. Is this correct? Diagram for carbon. K
Yes.
shell having
Yes,
2
sir.
electrons,
Yes,
L
sir.
shell having 4 electrons. Okay. So now I think you must have heard about the octet rule. What does the octet rule state? Is there anyone who is aware about the octet rule? Yeah, anyone?
Sir,
Yes.
The number of electrons in the outer shell should be 8.
Okay, number of electrons in outermost shell.
Sir, which are most stable or also they are in octet rule?
Yeah. So number of electrons in outermost shell should be 8 for stability, right? So if the element has to be stable, so it must have 8 electrons in the outermost shell, then we'll call this to be a stable element. So this carbon has 4 electrons. Now to achieve an octet configuration, only thing carbon can do is, like carbon can get 4 electrons. If carbon receives 4 electrons, so carbon's octet will be complete. Yes. If carbon receives these 4 electrons, so can I say that its octet is complete now?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes. So if carbon receives 4 more electrons, currently it has protons equal to 4. Sorry, protons equals to 6. It has 6 protons, electrons also 6. Now if it gains 4 electrons, so gain of 4 electron, will make carbon have protons equals to 6 and electrons equals to 10. Is this correct? The number of protons will remain the same, which is 6, and the number of electrons will increase to 10. Got it? Yes, got it now? Now see, anyone having doubt here that the number of electrons will be 10 and the number of protons is 6. Any doubts or confusion? Rijwana, Sudhamshu, Dhriti?
Sir,
Yes?
sir, I just joined. Can you once tell what you were explaining?
Okay, you joined just now. Okay. First of all, join on time. Okay. Otherwise, if you miss the beginning
Sir,
ones, yeah.
sir, actually, I had a school till now.
What you had?
School, I had actually had school till 16.
Okay. Okay. Fine. So, do you want your timings to be changed from 6:10 to 6:20 or
Sir,
6:15? Some. Yeah.
sir, can you only change the timings for tomorrow?
For tomorrow, do you have a class tomorrow?
Tomorrow and day after tomorrow, because I have a fest going on in my school, so I'm participating in that.
Okay, so I think then it won't be possible. I was thinking if you require an everyday change, then I could discuss. And if there were more number of people for the change. Okay, so you can just I would just advise to go through the video. For this topic, I'm repeating everything what we discussed up to now for carbon. Okay, so we are discussing the element carbon. The element carbon here. This is we are going with chapter carbon and its compounds. Okay, so carbon, it has atomic number 6. Atomic mass of carbon is 12 if it is carbon 12. If you take carbon 14, so atomic mass will be 14. Now the number of protons in carbon is 6. Since its atomic number is 6, so the number of protons is also 6. The number of electrons is also 6. And we have written the electronic configuration for carbon. So the electronic configuration of carbon, you have 2, 4. Right? So this is 2, 4 electronic configuration. So this we have represented here with the diagram. See, the nucleus having the 6 protons and 6 neutrons surrounded by the K shell having 2 electrons. Then you have the L shell. This is K shell, this is L shell. So K shell having 2 electrons, L shell having 4 electrons. Okay. Now we know that octet configuration is more stable. That is, the elements with 8 electrons in their outermost shell are highly stable. So, if carbon tries to attain the octet configuration, so there are two methods for carbon to attain the octet configuration. One method is by gaining of 4 electrons. So, if this carbon gains 4 electrons from somewhere, that means from any other element, so now this carbon will be holding 10 electrons. See, the situation for carbon will be like this. It needs to hold 10 electrons and it has 6 protons. Right? Whereas this was the initial situation. Okay. Now, the electronic repulsions of 10 electrons will be too high. And therefore, it won't be possible for a proton of 6, a nucleus of 6 protons to hold on to 10 electrons. It's almost double. 6 protons are going to hold 10 electrons. So this becomes a trouble for the nucleus the nucleus cannot hold 10 electrons. Got it? Since the number of electrons is large and inter-electronic repulsions will increase. Okay, so carbon cannot gain 4 electrons. Hence, carbon cannot obtain its octet by the gain of 4 electrons. So, Dhriti, can you tell why carbon cannot gain 4 electrons?
Yes, sir.
Can you explain why carbon cannot gain 4 electrons?
Sir, because carbon has 6 protons and it can handle only 10 electrons.
When carbon gains 4 electrons, the number of electrons in the valence shell become 10. Okay. Due to increase in the amount of inter-electronic repulsions, it becomes difficult for a nucleus of 6 protons to hold 10 electrons. Hence, carbon cannot gain 4 electrons and it cannot attain its octet by the gain of 4 electrons. Right? Then, let us try for the carbon to have a null valence shell. That means let's remove all the electrons of the K shell. That is another option. It can lose out all the 4 electrons from the L shell. So K shell will be fully filled and we can say that carbon is fully filled and now it may be stable. That is what the other elements do. For example, if we look at sodium, see what does sodium do? Sodium has a configuration of 281. Magnesium has a configuration of 282. Okay. So sodium loses this one electron to become Na plus and attain a stable configuration of 28. Mg, it loses these 2 electrons to become Mg2 plus and attain a configuration of 28. This is again a stable configuration. In the same way, aluminium has the configuration 283. So, aluminium loses 3 electrons to become Al3 plus. Again, attaining the configuration 28. So, why can't carbon do like this? Carbon has 2, 4. So, can't carbon lose the 4 electrons and attain a stable configuration of 2? Can they form carbon C plus 4 and attain a configuration like 2? Why is it not possible for carbon? Yeah, Siddharth.
Sir,
There
because
are
it is
only
lower
these 2
energy.
ways. Yeah, Siddharth. Anyone who can think of? Huria Ishaq? Moksha? Yeah, Moksha.
Yes, sir.
Why is it not possible for carbon to form a carbocation? That means losing 4 electrons and form C4 plus.
Sir, because it is already stable.
How carbon is stable? It's not stable. See, carbon is not stable. It's having only 4 electrons in the outermost shell, whereas it needs to have a fully filled configuration. As per the octet rule, the number of electrons in the outermost shell should be 8 for stability, or it should be fully filled. Either it should be 8 or it should be fully filled. Right? So carbon is not having a fully filled configuration. So it is unstable. Now, what it can do is it can either lose electrons or it can gain electrons. So we observed here that carbon cannot gain 4 electrons. The reason being the size of the nucleus is very small. So the attraction of the nucleus will be very less. Okay, the attractive forces of the nucleus will be very less. Got it? Yes, anything else?
No, sir.
Anyone else who can think of? Okay, consider carbon losing electrons. Okay, see it has 6 protons. Okay, the number of protons are 6 here. It has 6 protons. Now, if it loses 3 electrons, so it will be left out with 3 electrons. Now, the attractions between the nucleus and the electrons will be very large. The attractive forces will increase too much. Here in this one, you can think of like this. Suppose I remove this electron, I remove this electron, I remove this electron. So what should be the force of attraction now? There are 6 protons holding only 3 electrons. So the attractive forces will be very high between the protons and the electrons. And hence, it is not possible for carbon to lose all the 4 electrons. So, carbon, it cannot lose out 4 electrons, and also it cannot gain 4 electrons, and that is why carbon cannot form bonds by gaining or losing of electrons. Okay. So here we clarified that these 2 points we have clarified here. That carbon can't gain 4 electrons as it's not possible for nucleus of 6 protons to hold 10 electrons. Also, the next we saw carbon cannot gain or cannot lose 4 electrons as nuclear forces of attraction will be very high. To remove outermost shell. Okay. So both ways it's not possible for carbon. So we'll see in next class how it is possible for carbon to make the bonds with other elements. Okay. Anyone having any doubts? Anything? See, we have started with the chapter carbon and its compounds. Once we complete this, we'll be going on with revision of each chapter questions. Okay. All right. Bye all of you. See you again in next class.
Thank you, sir. Bye, sir.
Thank you, sir.
Bye, sir.